Hello, and there we go. We are live. So, hello. Welcome to another Raise3D Livestream. I'm back in the demo studio here with my two favorite machines, the Pro 3 and the Pro 2. The E2s are a little bit over there. We will be treating them with some love later, but just right now I have the Pro 2 with me. So for today, just going over some questions that have been sent in to us. We had some really good ones coming in through social media and our emails and stuff. So I can go through those. We'll just be talking about more general things, the material, the slicing software, our API a little bit, maybe getting into cloud. So topics going to be really broad today. And then I'll also be doing some maintenance work, some close-ups of just working on the machine and calibrating it. I know we had a maintenance stream earlier. That's going to go a lot over the steps of exactly what I'm doing, walking through that. But today I'll be working on the machines and just kind of talking about the questions that we have going on. But before I start working on the machine, actually, the one question that I did want to go over initially was someone asked how to print TPU. And there's kind of a lot to go into for that specific material. And certain setups and kind of the settings and what to look for when printing TPU. So to kind of go over that one, the TPU material is a lower temperature material. It's closer to PLA in how you would treat it, but that's mostly just because all the other materials would be a lot higher up. TPU, as far as the temperature-wise, is higher temperature than PLA. Sometimes it likes to have the bed completely cold. Sometimes it likes it more at 60. It's going to kind of vary from brand to brand because there's a lot of different types of TPU. So everything might be slightly different. That's probably one of the brands, not one of the brands, one of the types of materials that's going to have more variance from brand to brand, as compared to a PLA, which I would expect most things to be pretty standard across different brands of PLA. But on the machines themselves, there's a couple things you would want to do to specifically have the best chance of making sure that those TPU prints are going to succeed. One is having the lid completely removed if you're working on Pro 2. If you're working on an E2, that one can be fully enclosed. That one just runs a little bit lower bed temperature. And then the Pro 3s, since they do have the airflow management system in the back, that chamber right there, those are able to kind of cool off and circulate the air within the chamber, so it's not going to be as affected by having the machine fully enclosed. But for other machines in general, not just the Pro series, it's better usually to have a lower ambient temperature for that TPU material. Otherwise, if it is in a machine like this fully enclosed, more than likely it's probably going to have a little bit of that. I don't really want to see heat creep, but it can heat up a little bit prematurely, and then that's going to lead to it jamming like that. But with the lid off, so we're dealing with our temperature, the next thing I would want to look at is the extruder tension. So when it's feeding TPU, since that material is not as rigid as any other filament you would be running, we do have to kind of contend with the lack of structure as it gets pushed through the print head and eventually out the extruder. So for a rigid material, we can really, we don't want to fully crank down on the extruder tension here by tightening this. That's going to really bring in the filament feed gear. Usually we'll go pretty tight and then back it off, I'd say 3 to 5 turns just to give you a decent tension. So you can still kind of pull that out, but it is going to apply a lot of tension on a rigid material. That's going to help it feed better. But for a TPU, we would actually want to loosen this up quite a bit. And typically I'll go to a distance just where we can remove the thumb screw and then tighten it in a little bit more just until it's starting to tighten up again. Or if I'm running the load procedure from the touchscreen, I can just go in here, start loading. Once it gets up to temperature, it runs the filament feed motors. So while the feed gears are running, I would just load the filament in, have this undone, and then tighten it down just to where it starts loading and the thumb screw can be stable in there. And then that's the tension I would set. So we do want to have a really light tension on the filament when working with that TPU material. And then, so in addition to having the machine set up with that low extruder tension, and then making sure the enclosure is appropriate for which machine you're running. Next, we'd be looking at the actual slicing settings for these materials, and it can vary a little bit. The biggest ones are going to be something like a Polyflex, a NinjaFlex, and then of course our TPU95A by Raise3D. So we do have options for running those different materials just under resources at the top of our website, and then under the Open Filament program is where we would find the templates for our TPU materials. So again, if we're working with the Pro 2, we already have those templates ready to go. The ones for the Pro 3 will be coming out in the near future, so you can keep an eye on when those will come out. But working from these materials, there are options in here for Print Life's Yoga Flex. That's a flexible material. And then more specifically, we want to hit those 3 that I mentioned before, looking at the NinjaFlex and the Polyflex. So I'll go ahead and do our NinjaFlex profile, import to IdeaMaker. That's just pulling it over with a link. And then with that copied over, since I already had IdeaMaker up, it recognized that I was putting in a link. If not, I can just copy it here and then download. So now I have our NinjaFlex template ready to go, and I'll add that into our NinjaFlex material. So let's see. Then switching it over to our Pro 2, they just need to see that template. So let me import that again. I think I imported it into the E2, and I do want to have our Pro 2 up for that one. So there we go. So now importing it in, yeah, making sure that we're on the right material, and Ninja Tech. So then with the template in here, I'm just kind of looking at the differences between the NinjaFlex template and then our TPU95A, that's the Raise3D one. I can go ahead and compare, pull up the templates here, and then switching over to our TPU95A. Looking at the Polyflex templates, difference between those, just differences in the flow rates. Fan control speed can be different, so the NinjaFlex does use full fans for cooling, and then the Polyflex will run it a little bit lower. Same thing for the heated beds, they do run a little bit differently. And then a lot of the speeds are different. NinjaFlex is slowed down quite a bit for these templates. So it is, the most important thing is basically starting off with one of these templates to work with, and then from there we can kind of fine-tune things to deal with some of the issues that might be coming up really commonly with TPU. Looking at the Polyflex, NinjaFlex, and then comparing Polyflex to, or comparing our TPU95 to the NinjaFlex here. We are again running a slightly different retraction amount. The flows are higher on the NinjaFlex, and the temperatures are a little bit the same, but less things have been changed from this one to the Polyflex template. But mainly just really want to reinforce getting started with these templates for these materials is going to give you the best chance. And then depending on exactly the print results that you're seeing, then I would recommend more specific changes. Like we can adjust the temperature slightly, that may help. Cooling, we have the options here. So if we're working with areas that have, kind of really fine details, they might need a little bit more cooling or a little less temperature. So we can add in specifically what layers those are taking place, and then change our speeds at those layers. Same thing with the temperature control. If we did have that enabled, we can adjust those and fine tune those. The other options, usually I see a lot of stringing in TPU, and for that, it's going to help to enable a little bit of coasting distance. Usually I'll do like 0.2 millimeters. Basically, that's just going to stop the extrusion before it gets to the end of the filament path. So any back pressure in the nozzle is basically going to fill that gap and reduce the stringing as it moves past that wall onto the next section of the part. Z-Hop can help a little bit just for that travel, but the biggest one is probably going to be coasting for that string at the end. And then usually it's difficult to get perfectly clean prints off of TPU. More often than not, there will still be a little bit of stringing, and then I'll go over it with a heat gun and just kind of melt those wisps away, and they really aren't noticeable in the part afterwards. And then, so just going through the rest of the questions here, if there is an N2 plus trade-in program. We did, I believe that we do have some kind of trade-in program, but I unfortunately don't have all the information on that right now. It's actually best if we, on the website, if you are interested in looking for a trade-in, on our main website, just calling our phone number or emailing inquiry at raise3d.com, just contacting us directly. Then we can get you in contact with the sales team, and they would actually have information on if there currently is trade-ins and how we would go about processing that and what you'd actually get out of that. But for more information on trade-ins or the opportunity for any machine really, it's best to just reach out, inquiry, and then or call sales directly. And so, next question is how to get the first layer perfect every time. And that actually is kind of a more interesting question because it depends on what you mean by the first layer. I'm assuming the first layer is printing directly on the bed, and you would want to have that kind of pristine bottom surface, something that would be closer to something like these, right? Shooting for this level of surface. I'm assuming that if you're working with a raft, you're not trying to get a perfect first layer off of a raft or how to get the raft to adhere. We're looking for this perfect smoothness rather than just is the part adhering. That could kind of be perfect adhesion. But if we're looking for perfect surface quality, that's a big difference. The big thing for that bottom surface, if we're printing without a raft like that on any of these machines, the Pro 3s will default to just using a skirt, so they do print directly on that surface. They will get that finish like that. The Pro 2s default to using a raft, and that is mainly just for the best chance of adhesion. The automatic bed leveling on the Pro 3s does make it a bit easier to get that perfect first layer like that. And a lot of that comes down to the flow and the temperatures that you're running with, and then also the nozzle height. So if you are looking for a really, really good, perfect first layer, I'd say if you are starting with the templates that we have for those materials, so you're already working with the right settings, the settings are fine, then what we really want to look for is making sure that the Z offset is set to the perfect height essentially for that section. And it's not a height that you would be shooting for, I want it to be directly on the platform, or I want it to be extra close to the platform. I usually find that the best Z height for the Pro 3s, it should calibrate on its own, and again, you'll get that quality surface just from the Pro 3's calibrations. But on the Pro 2s, and actually on the E2s for that matter as well, they use the same bed leveling system as the Pro 3s. But on the Pro 2s, having that Z offset set is done manually with the feeler gauge and then the pin assembly on the side. So if I'm looking to get a really, really good first layer without a raft, I'll go here, and I'm basically just adjusting this point to get it where it's at a decent height. It should be still enough off of the platform that we get a good thickness for the extrusion width. It kind of almost, I would say it goes down in almost like a bead kind of thickness, so I don't want it to be so thin that I can clearly see the bottom of the surface through the extrusion. It should be thick enough that it is a fully opaque extrusion, and that everything is sticking to the platform, and we're not getting any stringing, or I guess not necessarily stringing, disconnect between the lines that are being laid down. So if I could run my finger over them and kind of strum the filament strands. That's too far away, but we are close. So usually I'll go for a height where it can just barely touch the feeler gauge, but there should be not a lot of pressure on that. It's really kind of just at the height of where it's touching the feeler gauge. Then I'll usually do 1/8 of a rotation towards the front of the machine. That just brings it down a tiny bit. And then from there we'll run the part. So it's kind of a feel of where exactly that specific height gets you the adhesion and the bottom surface that you're looking for. If things are too close or too high, unfortunately, it can lead to that rougher surface of things being pushed down too far, or they can, kind of come back up, and then you'll see a wavy lower bottom surface. Getting that perfect layer kind of is a matter of finding that sweet spot of the extrusion flow. So if your flow rate's going down, that can be adjusted a little bit. But I said, assuming we're already working off of the correct settings, then it's just a matter of making sure that the height is kind of dialed into that middle position, where it's not too close, not too far, but we'll still put down a nice, good first layer without a wrap on these machines. Oh, Stella, yeah, if I know we just went over the Z calibration a little bit. I hope that answered your question. If it wasn't enough detail, let me know and I'll go over it again. Hello, Samuel. Good to see you. Let's see, digging into the question for how to delete an old template. So we'll jump back into Idea Maker. So really, looking at the old templates, the ones that we can work with are going to be any of the ones that are not pre-built in Idea Maker. All the ones here that are, the Raise3D stock 4 templates, these 4 cannot be deleted. They are going to be kind of staying, they're built into Idea Maker. But for any other template, namely the NinjaFlex templates in here, I can either just select this template and then delete it on the right. That will get rid of this template. If I do have imported materials, then I can also just clean out the old material as well, clicking on the gear icon next to the extruder material selection, open up the filament menu, and then from there I just go ahead and click remove. And then I can choose, of course, which machines I'm removing it from. So we do have options, another pop-up here, to just say, no, I only want it removed from an E2, not from everything, or yes, I do want it to be completely wiped out of Idea Maker, so we'll just remove everything. And then if we are kind of working back with the default Raise3D templates, typically here I can create or duplicate new templates and then work off of these. And that's the same procedure here. If I have a template that's imported from Idea Maker or imported from the OFP or imported from another G-code, then I can delete those. If I'm creating new templates, I can delete those as well. But the ones that are stock and for the Raise3D materials, those can't be deleted. So on extruder tension. Yes, there were notes on, I did answer the question for TPU before. Sam, if you'd like me to go over it again, let me know and I will touch on those details. I'm not sure if you're able to catch them or not. And then is there a way to do a factory reset on the Pro 3? Yes. So getting into the Pro 3s over here, the factory reset options should be in our settings here. Then be getting into more settings, and then right here we have the whole option for reset. And then here we have the option for restore factory settings. So I would just want to go in there, and then from here this should clear everything for, this will clear all of the local storage. It'll also clear the filament profiles that are in here for loading. It'll basically wipe the touchscreen and revert everything back. And then again, that's just in the settings, more settings, reset, restore factory settings. And all right, so next question. We had a question about steel nozzles. Essentially just are steel nozzles on the Pro 2 abrasive resistant? And yes, they are, not just on the Pro 2, pretty much on any machine. If we are working with a stock machine, typically for all FFF machines, they're going to be running a 0.4 millimeter brass nozzle. And then if you're using really any abrasive material or anything that has an additive, then we would upgrade to just a more wear-resistant nozzle, and there are a couple other options. Specifically from us, we have a standard 0.4 brass nozzle, a nickel-plated brass nozzle, and then the hardened tool steel WS2 ceramic-coated nozzle. Those are the kind of main three options. The nickel-plated brass I'll usually recommend as just, hey, if you're trying out a new material or you wanted to use a little bit of carbon fiber, that material's a pretty good, or that nozzle, the nickel-plated brass one, pretty good go-to. It's on the lower end of the price range, so that's usually why I recommend that one just for getting started. But I think a typical brass nozzle is like $20, and then the nickel-plated brass nozzle is $25, available on our website. If you use my code FILAMENT, you get 10% off. But the $25 for the nickel-plated brass material, and then $50 for the full steel nozzle. So if you don't, you're not going to be doing a ton of carbon fiber, you can just use the nickel-plated brass for a little bit, and then still use those same nozzles for all of the original kind of pure materials. Because they do make variants of ABS and Kevlar ABS, PETG, and Kevlar PETG, or carbon fiber PETG. So if you can print the carbon fiber materials of those, you can still use the ones without the additives just fine without swapping the nozzle back and forth, and using the same settings essentially. With the nickel-plated brass or with steel, there's a little bit of a difference between the temperature coefficients to keep in mind, but I find that typically they still do produce really the same results with the same printing settings. But yes, you would want to just upgrade to the steel nozzle if you are doing any kind of abrasive material. Yes, so we did get a question on if it's possible to turn off the machine from the front. And if you're working with the Pro 2s, unfortunately, no. This is always going to be on, and the lights are always going to be enabled. They're kind of just plugged in there with the screen on all the time while it is printing. The Pro 3s and the E2s do have a sleep mode, just kind of one of the quality of life things that we added into these. But on the Pro 3s, if you do have one of the new machines, up here the moon icon is going to go ahead and just turn off the lights in the screen. It will continue printing while it does this, and then it just waits to be woken back up or interacted with again. The E2s will have on the side of the display, there's a red button next to that. If we touch that button, then that turns lights in the screen off. But it's just, unfortunately, we didn't have those features for the Pro 2s yet. So it's only on the E2s and the Pro 3s that we can put them in sleep mode like that. Okay, yeah, so I saw Samuel clarify it on the flexible materials, working with the extremely softer materials. It is kind of going to be, I would still recommend starting with that same process of having the extruder tension set really lightly. And then with those materials in general, the softer the material is, you might be getting into different needs for the flow on that material. I unfortunately haven't worked with the softest end of materials too much, but it is going to be a matter of, like, if we wanted to set the extruder tension, perfect. What I would go for that flexible material is find a temperature, look at what the manufacturer recommends for that material. Set that temperature here for loading, and then once it gets up to temp, it will start running the extruder motor in here. And if we have the thumb screw completely removed and the door open, it's really only kind of touching one gear. It's essentially being half extruded, so it shouldn't really be pulled down in yet with the door open and fully loose like this. once we put the filament door back in and apply a little bit of pressure, it should start feeding right away. And then you can see right now, like this is still basically entirely loose. This is to the point where I would not run the machine here. It's loose enough that it might, fall out. So I want to avoid that, tighten it down just enough to where it feels like it's more stable, that'll stay. And if it is feeding the material and it looks like it's extruding fine, I would leave it just there. We really want to be kind of as light as we're comfortable with, the softer the material is. But loading, again, as light as possible while it can still load. And that's where we're running the load procedure as we're adjusting the tension for this. So if it doesn't extrude yet, we do need to go a little tighter. But if it is extruding, then we want it to be as light as possible. And can the door feature on the Pro 3 be turned off was our next question. And it can. So I actually believe, I think it is disabled by default. But if it is enabled and we did want to turn it off, essentially it's just, there's an option on the Pro 3s for whenever the lid is off or if the door is open, it automatically pauses and then will resume again or waits till everything is closed up again in order to resume. If we want to print again with the lid off or what have you, say we're loading in material, a larger spool in from above, it's pretty common. We just need to go into settings, more settings, and then the advanced settings. So I'll actually go through all of these because there's a lot of things in here that I typically don't get to go into a lot of detail on. But the options in here for a lot of the extra kind of side features and quality of life things. So we have use fast stop up here. That's an option to essentially control how it's going to pause or how it's stopping prints. The use monitor should be the filament monitor. So there is an option to have the filament sensor actively enabling or disabling. That's actually going to be down here for turn on filament sensor. The preheat after print recovery, so if we have it, essentially if the power were to turn off and then turn back on, should it preheat again once it recovers that power. We have the options for clearing the info after the part is completed, so just how it handles exactly moving the display after it finishes the part. Cooldown after loading or unloading filaments, that is another big one. So looking over here, since I have the Pro 2's load procedure up, or I should. There we go. Yeah, it's kind of really close in here. The print head temperature is, looks like 128 and dropping. And that is because anytime we do a load procedure, it resets it back to 0. So I can manually set our temperature here, just typing in 205 on the display. It's holding 205. It's now increasing the temperature to hit 205. If I go into utilities and run a load procedure, it's now overriding that 205 setting that I had earlier, setting the temperatures to run at 220, and then once it hits 220, it'll start giving me the option to load the material. If I hit cancel though, back on the home screen, it does reset that temperature back to 0. So if I wanted to have a print be started, I'm starting print right away, I don't want that downtime of it, having an opportunity to cool down a little bit like that. We do have the option to make it so that way it doesn't reset that temperature after we finish the load process. And that's going to be that option right there. This is an option for recording serial logs. That one's not too important. And then cooldown after a print is paused, of course, just turning off the active heating while we're pausing. Typically not needed for most materials. Pauses shouldn't be that long. And then we have the option to control the distance for how far the print bed should lower after the print is completed. The option for lowering that, loading and unloading the timeout. So you actually do have the option to, if we are running a load procedure, have it actually stop after however long. I believe the options in here would be a number of minutes for how long it's running the load procedure in there. But that will just automatically stop it. So if for whatever reason, if you are loading a material and aren't there to stop it, this is going to make sure that it doesn't just run through the entire spool. Lower the bed after resuming from a power loss or after pausing. So that's just a little bit of an option for, again, how it handles the positioning of pausing and stopping. Power saving mode, that is another option in there. Powering off just the option for enabling or stopping the fans once it is idle. And then the last one's in here, that last option for pausing when the doors are open, and the setting for a timeout for the nozzle heating as well. So specifically to answer that question on the door pausing, that's going to be in the third page of the advanced settings. Let's see. Replacing the build tack printing surface for the Pro 3 using the build plate with a handle. So the process for removing the build tack on the Pro 3, wow, there we go. I actually don't know if I'll be able to get this build plate out of here. Someone cranked down on these thumb screws. Give me a second. Let's see, I should have. Well, that is unfortunate. I seem to have misplaced my tools and someone has tightened this beyond my finger strength. But just working with the surface in the machine. To replace the build tack surface, with the Pro 2s, it was, I'd say, a little bit less of a concern because the plates were rigid. So it's easier to kind of get under those and just peel them off entirely. On the Pro 3s, since they are that flexible plate, it's going to be the same process of trying to get underneath it and then peel that surface off. But I would be a bit more careful in how that surface is separating and making sure that you're not holding it in one hand and kind of pulling with the other. That we just don't want to bend the surface too much while we're trying to remove it. So I find that what I'll do is I'll put it down on the surface, kind of peel back the build tack a little bit, and then almost push it and slide it off, and that kind of peels off that section. But it's just not a full pull and lift and bend the plate. I'm trying to keep the plate as flat as possible, and then just kind of periodically peel it off and push it further back. That's the best way to get it off. And then once the surface is off, just wipe it down with 90% isopropyl alcohol. And then typically I'll put alligator clamps on it just to keep things in place, peel back one corner, lay that down, and then push all that out. But I believe we have a video that will kind of show more of those steps on how to actually replace that build tack. But the process is going to be the same for the Pro 2, just carefully removing the surface and then laying down a new one, clearing out bubbles like you would for a screen protector. Is it okay to apply the adhesive on the bed of the printer directly? So there's a couple of things. If we're working, well, it depends on what kind of adhesive. So typically if we're working with a 3D printing already approved adhesive, of course, that's where we would start with those. But if you're working with like a Magic Glue or a glue stick for any of these materials, then yes, you can apply them directly to the printing surface, directly to the build tack surface on that. It's typically not required for most materials. Usually we only recommend them for polycarbonates and nylons. But if you did want to just have the extra adhesion there, in my experience, glue stick really always helps. But you would just go ahead and with one of these here, you would just go ahead and apply it directly to the surface itself. You do want to make sure that you actually have the printing surface on top of the platform, not just the platform. If you're printing directly on the metal, really no amount of adhesive is going to work with that. It does need to have this surface. in order to stick, it's really not worth having, trying to get parts to not stick to the surface. It doesn't really work in my experience. But for applying directly on the surface, I'm kind of working this region, so I don't want to mix my adhesives. The kind of general technique for applying adhesive to the surface, I'll usually go in horizontal lines or lines in one direction, and I really want to cover the area where the part is going to be and a little bit extra. So I kind of give it, you know, an inch of space around the part just to make sure that everything is fully covering that area. I'll do lines in one direction and then go back over it the same way to make sure that I've fully coated that area. And then that's definitely enough. Just going through there, but it was basically kind of 3 to 4 passes going in 2 different directions, making sure that I get full coverage of the area. And basically that surface is ready to start printing on. But making sure that things are very evenly kind of laid down, evenly coated, and changing your directions like that helps a lot to make sure that the adhesive is properly applied. And then usually all of the adhesives like glue stick and magic glue, those are going to dissolve in water, so we can just take the build platform, run it under water and wipe off all of the residue from that, then clean it off with 90% isopropyl alcohol or higher, and then reapply that layer with the same technique essentially. So we can, if we are using adhesive, reuse the same surface and refresh the adhesion on top of that surface. Okay, yeah, and I did just see, yeah, magic glue on the build tech. Yeah, everything that I just described is what you want to be doing for that. And then so we did have another question. How hot can the chamber get on the Pro 3? And that is something we don't actually measure, or it's not an actively heated chamber on the Pro 3 machines. It is kind of passively heated by the bed. So we'll set the bed temperature to 60 or 100 C, and then with the lid on, it's just going to be kind of the ambient temperature around that. So I would expect it to be close to 100 C, but not consistently holding 100 C the entire time. But it is enough to kind of slow down that cooling for all the materials that need it and give them you know, the ambient temperature that they need. It's really for the higher grade, the most extreme temperature materials like PEK and PEI that need an actively heated chamber to maintain that high temperature. But for all the materials that rerun, running the bed with the machine enclosed is enough to keep a high enough ambient temperature in the machine that I don't have to worry about, you know, how those parts are working or if they're getting too cool. But typically, if we wanted to kind of measure it, having another kind of thermometer in there will let you know what the temperature is ambient, but it's mainly controlled by the surface. So that's going to be your biggest limiter, and I really wouldn't want to fluctuate that temperature too much either, because it's the biggest factor on getting parts to stick is going to be more the surface temperature rather than the ambient air temperature. Is there a textured build plate in the works? So I believe that as far as the build plates and build surfaces go, we are sticking with the build tech surfaces, but for the Pro 3s, I believe that we are having options for other build plates that will be coming out. So normally it'll have the flexible plate, but if you did want to go back to the rigid plates like on the Pro 2s, I believe we are coming out with other options for those. And then I'm assuming the textured surface I'm looking for would be like the PEI coated surface. I do not believe that we have plans for any textured surfaces like that, at least as far as I'm aware. And then, so what do we recommend for printing PP with the Pro 3 series? So yeah, polypropylene is a very tricky material. That's probably one of the most I wouldn't say aggressive warping materials, but it does have a lot of warp on it. If we are running the polypropylene materials, there's a couple options. I believe that BuildTak does make a polypropylene additive that would be put on top of the surface. That one has worked as a good kind of, hey, I want to use this machine for polypropylene and everything else. You just put on the BuildTak polypropylene additive and then print on that. I would recommend that one. The Magigoo also has a polypropylene additive that I have used as well. That one still does work, but I think I would probably say the BuildTak polypropylene maybe was a little bit better, but I would really want to go back and double test them again. The one that I had the best results with, the PP Print, the company that makes the polypropylene off of the Open Filament program. If you go find them, they're alphabetical. PP Print makes a surface that is a P surface. It's made for printing polypropylene on it. And then they also do the P support material. If you're using P support on the P surface with the polypropylene as the main part material, hands down, that's the best way to get parts to adhere to the surface, have really good supports, and have them be pretty easy to remove. Just kind of as an example for the polypropylene results. This print, I know it's all kind of white and blown out, so it's difficult to see the details. But this print is all polypropylene, and this was actually printed in this orientation. So all of this in here is supported. And using the P support material, essentially printed out all the support structures underneath this. It is treated a little differently in how you remove it. It does like to be dunked in essentially boiling water, and that softens up the support material, and you almost remove them like a gum. And that's how they recommend to remove it. So I would follow their instructions on removing that P support. But yeah, the P support with the P surface, those are the best results. Second to that, I'd probably say the Magigoo PP and the BuildTak PP additives on that same surface are going to be the next best one for polypropylene. And then let's see, is it possible to print with one nozzle and support in the other nozzle? Different colors, help differentiate knowing what should be removed, like what is the part and what is support. Yeah, so if we just wanted it to be kind of for that specific application, looking at just having two different colors so you know what needs to be removed. If we are working with materials that are similar in, I'd say, the final kind of final material properties, so like a PLA and like a poly support that's actually made to be a pretty decent breakaway support material, we can just bring in one of these parts here, bring in our fan duct, clear out my group and layer settings. The main thing to do for like a poly support, if we're working with just a standard PLA template or any other template, if we're using the same exact material, just to have a different color for the supports, all I need to do is go into the template, click on Edit, and then under the Support tab, set the support extruder to the right extruder, and then that's just going to run with the right material. I don't need to do anything else if I just want it to be a different color. If I'm running a slightly different material, then I would want to just match the temperature for what's recommended, say for poly support, and then whatever that is, then have that set here, and it would still follow the same parameters for using PLA. Under the extruder tab, this has all of the options for things like the extrusion width, the amount of retraction, the travel, and things like that. If we are running different materials, sometimes we might need to get into the right extruder configuration and enable a different configuration. This basically allows the left and right extruders to run different settings from each other. So I think the TPU likes to have a 0.5 extrusion width in some templates. We would need to match that. And then also just kind of, again, making sure that cooling is going to be the same for both materials, as well as the temperature range. The temperature and cooling compatibility is really important if you're doing any combination of those. But for a really simple one, things are pretty similar. Right extruder, and then making sure your temperature is set correctly and that the cooling is the same. PLA and poly support. That's really all you need to do to get that combination going. and then just to see the slice preview. To confirm that we do have the parts set up for the left and the right, I always go through our preview here, and then looking at structure extruder color. Yes, we are running the part out of the left extruder, and all the supports are just being run off of the right side. Let's see. Oh yeah, someone did ask about the disable icon. So yeah, just to clarify on the utility screen. Let me see. The printer Z offset adjustment. Why does it always have the disable motor icon? And is there a way to make that go away? No, the disable motors icon is always going to be there as a button and not a status indicator. But just really kind of any time that I need to move the print head or wanted to work with filament or the extruder motors as well, just disabling that disables everything. Then I can move it safely by hand, but that icon is always going to be there. Okay, and then I think the last question that I'll touch on, unless we get anything else in chat, we did have another that came in that was, is it possible to change filament if during a print finishes? I think what they're asking is it possible to have it switch over after if it runs out of material, essentially? Thinking if we have 2 spools in here, we fully run out of one spool. Does it know that it has another spool available, and could it switch over? There's a lot of stuff that goes into why that's complicated to do. It would essentially need to be able to rewrite G-code on the fly, which it doesn't do. So it is possible to set up something similar, but it does not automatically do that on its own. The way to set up that similar process would be looking at a part like this. We're looking at about 10 grams of filament. If we were to scale this up, essentially what we can do is I can scale up one body, 300% should be close enough, and kind of get an estimate of how much material this would take. So if we want to switch it back, I'll restore everything. We'll go ahead and kind of max out our infill usage just so I'm using a lot of that material. Yeah, we'll do 30. Yeah, there's a little bit of a process in order to set up something like this. If I intentionally knew that we were going to be using upwards of one spool on any given print, I would really be setting the part prematurely to know, hey, it's going to switch over partway through. So all of this, I can either run the parts and supports. That'd be a good way to kind of transfer the material. Yeah, this one's not even using a full kilogram, and it is also still one color. So I'd say we're probably doing maybe half and half. But I would basically want to go in here, find a part where I know that it is going to use a full kilogram of material for half of the part. I can bring up our free cut tool so I can set a cut plane. I'm only working specifically with the height here. So I can split this. This gives us our 2 part bodies. They do have non-manifold edges because of the cut that I put in, so I kind of want to just repair those really quickly and make sure they go back to the correct color. That one did have a little bit of a face issue there, so I'll leave that one alone. We can go ahead and have our upper section set to the right extruder, and then we should be able to reslice this. Just really knowing how much of the part I'm going to need for the right, cutting it, setting that section to the right extruder, and then just letting one of the 2 extruders also handle the supports. That's the one caveat, is that not everything switches over. it's going to be easier to just have the supports printed with one of the two sides of the extruders, and just have it split so we know we're using more material for the right side there. And that just, of course, basically fluctuates on where you set your cut placement. But yeah, and then looking at this one, I would also probably go into the advanced settings and either just change it to a white tower. That's going to be probably easier. It doesn't need that much space to wipe off on that, or you can disable both of them, since again it won't be using one of the two extruders for most of it, and then it switches to dual partway through. So we have options on how we want to handle that ooze, but really if we did want to set up a pausing or a switching like that, that is essentially how we would do it with these machines, how they are currently set up. Yeah, so I think that's going to do it for our stream today. I want to thank everyone for tuning in and posting questions. I think it was awesome to see everyone here. I did get another one in. What do you recommend for lubrication on the Pro 2 and E2? Frequency, grease versus oil. So as far as frequency, on all of our machines, we recommend relubricating the gantry rods and the Z-axis every 300 print hours. And all of the machines will track the total print time on the dashboard. So if we go to print and then dashboard on the right, up at the top here we have print time, and that's the total time for all prints on the machine. So I'm looking at 77 days on this machine. Every 300 print hours is every 12 and a half days according to this. So basically just keeping track on that, 12 to 13 days, come back in and then relubricate the upper gantry. And the material, or what we recommend, is going to be this one. On these machines, we will run Super Lube silicone lubricating grease with PTFE. I believe the specific one is part number 92003. But yeah, if you wanted to kind of figure out more about this one, just emailing us or asking, make a ticket, open for tech, we can send more information on this specific lubrication that we use. But it is a silicone-based lubricating grease with PTFE is what we recommend. And then recommended ways for removing rafts. Someone else did ask. So for removing rafts, it depends a lot on the material. If we are working with like a PLA, usually those don't adhere too much, and well, more often than not, just removing a raft should be basically as simple as holding the part and peeling it off the bottom. If they break off, or if they do still stick on, then I'd say using a thin scraper or something we can maybe try and get under there and separate them. It's kind of the same process that you would kind of thinking of how to remove parts from the Pro 2 surface, kind of the same idea. But if parts are sticking really aggressively to the parts like that, and it's not easy to peel them off, or it's too difficult to get at them with tools, in Idea Maker there is an option under Edit in the Advanced Settings under Platform Editions. We can set the specific value for the raft gap from model. So if we increase this value, that will make the rafts easier to remove. If we decrease this, that brings the part closer to the raft so they bond a bit stronger. If we increase it too much, then we might get really rough, ragged surfaces, or the parts will not stick to the rafts at all, so you want to be careful about that. But just increasing this value a little bit should make those rafts easier to remove to get you to that point where you would be able, again, to just go ahead and peel them off like that. Adjusting the raft gap will make that more possible. Okay. Yeah, so then that is going to do it for our stream today. I want to thank everyone for coming in, tuning in, submitting questions. Awesome. Love having people, chatting back and forth. And I think I'll probably go into, I want to get an update on a couple of the other projects that are going on, but it's been long enough. We're going to go ahead and I'll end it for today, and we'll see all of you in the next stream, hopefully. As always, I've been Nick. Thanks for joining.